Okay, good morning, everyone. Thank you for coming to this session. This session is multi-cloud Ingress LB, Gimbal use case in Actapio and Yahoo Japan. So today, we're gonna talk about Gimbal overview and how Yahoo Japan uses and operates Gimbal. First, let us introduce ourselves. I'm Hirotaka Ichikawa. I'm an engineer of Actapio. At Actapio, I cover a wide range of infrastructure engineering, from data center to cloud. It's a full-stack infrastructure engineering. Then, what's Actapio? Actapio is a US subsidiary of Yahoo Japan. We are based in Washington State. In Washington State, we operate data center for Yahoo Japan. We have just one data center now, but next week, we're gonna open the second one. It is big, and it has a capacity of up to 16 megawatts. We also work for accelerating software-powered infrastructure solutions, such as load balancing, application monitoring, storage, and so on. We cooperate with Yahoo Japan on these efforts.
Hi, I'm Ryutaro Inoue. I'm Senior Manager of Yahoo Japan Private Cloud Division. I'm in charge of OpenStack, OS, EAS layer in general. I was responsible for network security in the past. I also have knowledge about network and security. Let me introduce about Yahoo Japan. Yahoo Japan is a joint venture between SoftBank and Yahoo Inc. But Yahoo Inc. was bought by Verizon. We are independent, but we are independent. We run many services, for example, news, auction, weather. There are over 100 services. We have 72 billion page views per month and 10 data centers and 100,000 servers, over 60 OpenStack clusters. Most of our services run on OpenStack. Currently, we are migrating our infrastructure to Kubernetes and Cloud Foundry from OpenStack.
Okay, let's start talking about Gimbal. What's Gimbal? Gimbal is Layer 7 Ingress load balancing platform built by Heptio with Actapio and Yahoo Japan. Gimbal works on Kubernetes ecosystem and provides a scalable, multi-team, and API-driven ingress tier. Gimbal is capable of routing internet traffic to multiple upstream clouds, such as Kubernetes and OpenStack. Before talking about detail of Gimbal, I would explain about two whys and our background. The first question is why we need Gimbal. The purpose of this project is bridging the gap between virtual machines and container. As Ryutaro said, Yahoo Japan has many VM-based workloads on their OpenStack private cloud for supporting over 100 services. We have started migrating to Kubernetes, but it is very hard to migrate all services to new platform at the same time. We required solution that helps migration and coexistence of multiple platforms. So we approached building multi-cloud load balancer. It supports both of VM and container cloud, and making migration from VM to container easy, and optimizing operation cost by providing large single load balancing tier across cloud. In addition, we expect it for modernizing our traditional application delivery. Application delivery at scale is key to our business. We needed faster service discovery and canary deployment capability that provides instant rollback and performance measurement. Gimbal enables our developers to address these challenges, which at the macro level helps them increase their productivity and optimize system performance. The second question is why we collaborate with Heptio. To achieve these challenges, we asked Heptio for help. They are deeply expertise around Kubernetes and cloud-native technologies. Also, they have tight connection to open source community. By cooperating with Heptio, we could reach out to higher level solution. Proceeding with the project in open source world enabled us to provide the environment where we could create more sophisticated solution with the people who had the same challenges. I would like to take this opportunity to express our appreciation to the Heptio project members. Thank you very much. It's there. Okay, let's move on to the Gimbal technical part. This slide shows the Gimbal architecture overview. Gimbal consists of a couple of components, and they work on single Kubernetes cluster. This cluster works as load balancing tier. From here, ingress traffic is routed to backend upstream clusters. In Gimbal, there are three main functions: routing and policy, service discovery, and monitoring. Developers can control routing policy by themselves using kubectl within the scope of their granted authority. Service discovery function shows developers available service resources to configure appropriate routing rules. It follows the change of upstream instance and pods and applies the changes to routing policy. Gimbal exports metrics to Prometheus. Developers are able to see their request activity, and operators are able to see cluster activity. Let's see each feature details. First, service discovery. Gimbal discovers services and endpoints from upstream cluster. Discovered services from upstream clusters are stored in Gimbal cluster. Developers can find those services in their namespace on Gimbal cluster. Discovery agents are deployed to Gimbal cluster for each upstream cluster. Currently, Kubernetes and OpenStack Discoverer is available. Regarding Kubernetes Discoverer, it watches upstream cluster event and synchronized services and endpoint to Gimbal cluster. Regarding OpenStack Discoverer, it pulls OpenStack Neutron API and imports LBAS data. OpenStack Discoverer treats OpenStack project as Kubernetes namespace. This slide shows command line outputs of discovered services. Discoverer stores upstream services as local service and endpoints. Services are created as headless service, so there's no cluster IP. It has upstream cluster name at the beginning of service name. Once synchronized, services show up in the theme namespace with cluster name. Blue letters are services imported from Kubernetes upstream cluster. Gimbal stores upstream pod IPs as endpoints. Red letters are services from OpenStack upstream cluster. Load balancer UUID from OpenStack is used for service name. Endpoint IPs are VM's IP addresses. Second, routing and policy. This part is the most important and supported by Heptio controller. Controller is Ingress controller powered by Envoy. Unlike standard Ingress controller, it has advanced capability, such as wedge shifting, load balancing method, and cross-cluster backend. To achieve this capability, Contour introduces new Ingress API using custom resource definition. Contour is closely related to Gimbal, but I don't mention so much about Contour in this session. Sorry about that. This is an example Ingress route configuration. Developer creates Ingress route configuration in accordance with their discovered services. In this case, it has two services with weight values and destination port. Ingress traffic will be forwarded to pod or VM directly. It doesn't go through the service or Elbus load balancer. Because of this direct forwarding, we aimed at simplifying the network and reducing network hops to maximize performance. Lastly, monitoring and observability. Gimbal provides Prometheus monitoring and Grafana dashboard. Currently, there are three types of dashboard. The first one is Envoy dashboard. It shows RPS, CPS, and latency for each upstream services. Developers can control the balancing weight in accordance with upstream service activities. The others are Gimbal dashboard and Contour dashboard. These are mainly for operators. They show the number of upstream clusters, replication status, and ingress routes. Gimbal is ready to use now, but as I mentioned, it still has a limitation regarding network. For Kubernetes upstream cluster, pods should be reachable from outside the cluster directory. It means we need to configure host network true on pod configuration or advertise pod network to outside of the cluster. In our case, we use Calico to advertise pod network to outside. This limitation will be the next step to be solved. Okay, let's move on to Gimbal case study at Yahoo Japan.
Okay. We built this cluster structure in our production environment. We will put this structure at each data center. Hardware specs and OS information are shown in the table like this. Traffic from internet and other data centers goes through hardware L4LB and into Gimbal cluster. L4LB uses DSR, direct server return, So returning traffic doesn't go through L4LB and has better performance than inline mode. By increasing the number of Envoy pods, we can scale the performance linearly within the performance range of L4LB. Gimbal is running on Kubernetes. There are 3 master and etcd nodes and 10 worker nodes. Each node has 10 giga interface. And one worker node has 1 Envoy pod, and Envoy pod uses host network to maximize the performance. This slide shows how we use Gimbal at Yahoo Japan. Applications are developed and operated for each service. Gimbal must have namespace isolation function. Each service admin manages virtual machines and pods on the endpoint side and has permission to edit config on Gimbal namespace for service here. For example, new service admin has their pods and VMs and news namespace in Gimbal. Also, there is Gimbal cluster admin. The Gimbal cluster admin manages the entire clusters and has permission to admin namespace. Yeah. At Yahoo Japan, Gimbal is used as follows. When beginning of use, firstly, service admin sends a request to Gimbal admin via ticketing system. We use Jira. This request contains namespace and FQDN information. Gimbal admin makes a kubeconfig file with authority for service namespace that was specified in the first step. Then Gimbal admin creates the FQDN in the admin namespace. We use default namespace as admin namespace. I will explain this step in detail later. Next, Gimbal admin sends the kubeconfig to service admin. Service admin starts to edit Gimbal ingress route with their kubeconfig. And then service admin changes their service DNS-A record into Gimbal cluster's IP. Then service will be able to use Gimbal. Next, when modifying ingress route, Gimbal admin doesn't need to do any work. Service admin modifies Gimbal cluster config anytime, and setting is immediately applied, and there is no connection loss. When service admin modifies their backend, Gimbal discovers this automatically and applies the change to ingress route. As a result, when endpoint is added, traffic also goes to newly added endpoint automatically. This is an example config. There are 2 namespaces, admin namespace and service namespace. Admin namespace can be edited by Gimbal cluster admin only, and service admin can edit config in their own service namespace. We use counter delegation function to prevent disorder and duplication of FQDN. FQDN can only be defined in admin namespace. It means only Gimbal cluster admin can define FQDN and delegate config to service namespace. In order for the delegation function to work, the name of delegation in the admin namespace here must be the same as the name of ingress route here. And then service admin specifies their endpoints and its port ratio and etc. in their namespace. We'll move on to the performance testing now. We conducted performance testing in this environment. There were 10 virtual machines in the workload cluster. We used HEY as load generator. This is fast HTTP load generator software. In the Gimbal cluster, we used 1 Envoy pod in 1 physical machine. This machine had total 32 core and 64 threads. Envoy version was 1.6.0. In the backend cluster, we had 10 virtual machines and used Nginx. Nginx had 3 data sizes of contents: 1 byte, 1 kilobyte, 22 kilobyte. 22 kilobyte is average data size at Yahoo Japan. We connected these 3 clusters with 10G interface and then carried out performance testing. This is the test result of P99 latency at each RPS. We aimed latency less than 30 milliseconds. 10G bandwidth became saturated when the data size was 22 kilobyte and the RPS reached over 50 kilo requests per second. So it was impossible to measure any more RPS in this environment. We can't get these values. Yeah. In other data sizes, the latency was getting worse in stages, but cleared 30 milliseconds as the target value. There was not much difference in latency between 1 byte and 1 kilobyte. This is the result of CPU usage in Envoy pod at each RPS. The trend was the same as that with latency. At 22 kilobyte data size, 50 kilo requests per second was the limit. Yeah. The CPU usage was rising in proportion to RPS. At 300 kilo requests per second, the CPU usage was about 80%. So there appeared to be more capacity, but we couldn't test further PS because of backend port limits. This is a comparison of latency when increasing the number of ingress routes and endpoints. The number of endpoints could not be set to 100 or more due to the limitation of the testing environment. Even if the number of ingress routes and endpoints increased, there was no effect on latency. These graphs are flat. So the conclusion of performance testing. An Envoy pod achieves 300 kilo requests per second at 1 kilobyte data size. There appeared to be further CPU capacity, so it could potentially achieve 350 kilo requests per second, maybe. It scales linearly in terms of structure. 10 Envoy pods will achieve 3 million requests per second. If it is not enough, we can increase the number of Envoy pods easily. And no degradation of latency was observed when increasing the number of ingress routes or endpoints. Then what we will be doing in the future includes first, expansion of usage in Yahoo Japan production environment. Currently, Gimbal is released in one environment at Yahoo Japan. And developing faster OpenStack Discover. We currently have 4,000 OpenStack projects and 1,000 of OpenStack load balancer VIPs. It takes 30 minutes to discover all VIPs. However, it is not necessary to discover all these VIPs. We are migrating our infrastructure from OpenStack to Kubernetes, so the number of OpenStack VIPs that Gimbal actually has to deal with will be small. We would like to implement a function that can specify which project to discover, and this will speed up the discovering. Currently, there are hardware L4LVs in upstream of Gimbal. We would like to change this to software L4LV. This will allow Gimbal to scale further. And developing GUI. Currently, the ingress route setting is made via kubecontrol command, but not all employees are used to kubecontrol operation at Yahoo Japan. So we would like to have a more user-friendly config system by developing a GUI that can be set up more easily.
To summarize this session, we introduced Gimbal overview and how Yahoo Japan uses Gimbal and a performance test. Gimbal is layer 7 Ingress controller for multi-cloud environment and bridge the gap between VM and container world. It also provides modern application deploy features to Ingress tier. This Envoy-based load balancer is well tested at Yahoo Japan production environment. They will expand the use of Gimbal in their production environment. And pull request is welcome. Thank you very much. If you have any questions, we are available at Heptio booth from 12:15 to 13:45.
Thank you.